Okay, comparison tests for convergence, divergence. Comparison tests for convergence and divergence. What time are we getting out of here today?
18.
1:18. All right. Okay. So you don't have to write this first part down. Okay? Just watch for a minute. What do you know about that series? Converges because p is greater than 1, right? So this is a convergent p series, right? It's a convergent p series. How does this series, this is n cubed again, sorry. How does this series compare to that one?
Same thing.
Same, except like moved over slightly. Well, the one is irrelevant.
The one is relevant. The one is very relevant for this situation. Okay, look at the title of the section, comparison tests. Okay,
Because if you compare it.
what is the comparison? You told me that this is a convergent p series.
So,
So what do you think about that one?
well, that should also be converted.
Why?
Because it's incredibly similar.
When you, don't you have to,
Thank you, Michael. The denominator is slightly bigger, which means that the whole function is slightly smaller. Growth rates, people, growth rates. We have to understand growth rates, okay? If 1 over n cubed converges to convergent, then this one must also converge because it is what compared to that one? Smaller. Okay, so you're back to this idea of what we just talked about with the integrals, right? With Mary. If this converges, and then you come in and you draw this, which is slightly smaller, it will also have to converge. That's a direct comparison, okay? Then we can do something called the direct comparison test. I'm going to write it out for you in just a minute, okay? But do you guys understand why you can say this one converges? Do you understand that the plus 1 is significant?
yes.
Yeah, because the plus 1 tells you that this is smaller than that one. If it was minus 1, can I do anything?
Well, no, you don't know how.
No, because I don't know how much smaller it would have to be, right? Okay? All right, so what do you know about this series? What do you know about that series? That's a divergent p series, right? That's a divergent p series. How does that compare to that? Slightly larger. It's slightly larger. So if this one diverges and this one's bigger, then it would also diverge.
So it's like the same.
What if it was,
Yeah, exactly, right? Because I know this one diverges, right? This graph is not going to this graph is not going to approach the x-axis quickly enough for there to be a finite area.
So if you
To compute.
add something, then it doesn't matter, right?
If I added something here, it wouldn't matter because I don't know enough. It's got to be on the correct side of what you're comparing, right? If what you know diverges, then the thing that you're being asked about would have to be what? The function that you've been given would have to be bigger so that you can say that it also diverges. But if you know that some function converges and you want to compare it, you're looking at your original one. Your original function would have to be smaller than the one you're comparing to talk about it converging. Does that make sense?
Can you graph that real quick?
This one, kind of like I did that one.
Yes.
Okay, so this one, this is divergent, right? So then what we're saying is we bring in this next function,
Okay, that makes more sense.
and it's bigger.
Because it's still going at the same thing, but it's even higher.
Yes, but it's even higher. Exactly. Okay? All right, so that's a direct comparison test. So let's write that thing down.
Yeah, well, I got like 50.
All right, so the direct comparison test. Assume A sub n and is greater than 0 and B sub n is greater than 0. Okay, and A sub n and B sub n are representing term generators, and you'll see I'm gonna write them as such. If the series from n equals 1 to infinity of B sub n converges.
I was writing this out.
I'm sorry. If the sum from n equals 1 to infinity of B sub n converges and A sub n is less than B sub n, then the series from n equals 1 to infinity of A sub n does what? If B sub n converges and A sub n is less than B sub n, then this one also converges. Good. And I don't suggest memorizing that statement, okay? You have to, think about it. Think about the growth rates, but here it is summarized for you, okay, so that you do have it.
So you're saying we
To
have
go
to think
to.
about that statement for a second? Oh, Brianna,
I'm sorry.
Okay, so here's the second thing we can say. If the series from n equals 1 to infinity of A sub n diverges, so series from n equals 1 A sub n diverges, and B sub n is greater than A sub n, then what can I say? The series from n equals 1 to infinity of B sub n also diverges.
Is there a reason your B is lowercase?
No. No.
Yeah.
Okay, so let's do a couple of examples. Everybody got that? You're coming alive, Brianna. I said you're starting to come alive.
Zigzag Z.
All right. So we want to determine convergence and divergence. We've got 3 examples for you to look at here. Okay, I want to determine convergence and divergence. So the first one is a series from n equals 1 to infinity of 1 over n to the 4th plus 1. What's that going to do?
Converge.
Converge. Why?
Because the series from n equals 1 to infinity of 1 over n to the 4th is a convergent B series, and that is greater than.
How about that is
That is
smaller
less
than
than
that?
one.
Yep, there you go. Perfect. Okay, so I'm going to write out the rationale just so you can have it to look at later. Okay, Again, like on a quiz, you would need to say something like what Kevin said for right now, okay? But on an AP, you're going to see this as multiple choice. So compare to that, which is a convergent p-series. Since 1 over n to the fourth plus 1 is less than 1 over n to the fourth, it also converges.
And P series is only 1 over n to the power. It's always gonna be in that format.
Yes, ma'am, it will. You can see where knowing your p-series rules are very important, right? Because you got to know which one converges and which one diverges if you're going to do a comparison. Okay, let's look at this one. The sum from n equals 1 to infinity of 1 over 3 to the n plus 2. So that one looks a little different.
So just making sure that if it's convergent and say it was like 1 over n to the fourth minus 1 because it's bigger, that means you can't determine whether it's convergent.
Exactly. Then I could not determine anything with that test. Okay. All right. So what do you think about this one? I could compare it to, I heard Emma say geometric good, and then I heard Elise say compare to this. Oh, okay, sorry. A ventriloquist over there. Okay, and then some people prefer to write it like that because that helps them see that as geometric more than that does. Okay, whatever you need to do is fine. Okay, and then what do you know about this?
It's less than 1, therefore it converges.
Which is a convergent geometric series. Okay, so now what can I say?
We have to say geometric.
Well, because that converges and because
Since that one's
1
less than
over 3
Since,
plus, it becomes
since 1 over 3 n plus 2 is less than 1 over 3 to the n.
Yep. Since this is less than 1 over 3 to the n, it also converges. Is this making sense to you?
Yes.
Okay. Do you see that it really is sort of the integral test as well? It's kind of, if you think about it, it's kind of the same. If the integral converges, right, then and you draw your rectangles such that those rectangles are below the curve, then your series would also converge. Okay? Yes, Michael?
Like, for number 1, I don't understand whenever it's like, if it was minus 1, why do you
Yep.
determine
Because 1 over n to the fourth converges, right? But if this is n to the fourth minus 1, this is now bigger than that, which it might be just big enough that it no longer approaches the axis fast enough. Y doesn't approach 0, you know what I mean? So you wouldn't know anything.
Would they ever give you that kind of question?
Yes, it's not that they're going to give you that kind of question. It's that you are going to have to make the choice as to what to compare it to. And you're going to have to make the right choice. And some of them are harder to see than others. The ones we're looking at right now are pretty easy. Okay, but some of them are much harder. But when they get much harder, we have this other thing called a limit comparison test that helps us out. Okay? All right, let's look at this one. The sum from n equals 8 to infinity of 1 over the cube root of n minus 1.
The cube
1 over the cube root of n minus 1. So what do you think?
Is there a particular reason why you made n start at 8?
Yes, if it's anything less than that, it'll put a negative down there, and I'm dealing with all positives.
Okay.
Diverges, okay? So give me your rationale, Emma.
Because if you compare it to 1 over the cube root or the square root of n, then it is less, greater than.
Okay, and what is this? This is a divergent P series. Okay, and then since one,
The original one is greater than the 1 over cube root.
it also
It also is divergent.
diverges. Just checking my time. I got 11 minutes. All right, we feeling pretty good? Okay, so you've brought up some good questions along the way. Like, okay, so what if it's not, what if I know what I have picked converges, but what I'm given isn't smaller? Well, then you have to choose something else. Or the other thing that happens is you don't know how they compare. Okay, so think about this one. You don't have to write this down yet. Think about the series from n equals 1 to infinity of 1 over 3n squared minus 4n plus 5. So think about that for a minute. What would you start with if you were doing this problem? Nth term test, right? I do the limit as n goes to infinity, and I would get what? 0, which means I need to do some more work. Okay? Is it geometric? No. Could I do the integral test?
Yes.
I could do the integral test, but what would I have to do?
Make all parts.
Part, yeah.
Partial fractions, if that even factors. Right? Okay? So then the next thing I can ask myself is there something I can compare it to? What could I compare it to? I could compare it to 1 over n squared, right? I know that 1 over n squared is a convergent P series, which means that this would have to be what?
Would have to be greater than.
No,
that's the worst.
I was still switched in my head.
Okay, so one more time. If I compare it to 1 over n squared is a convergent P series. If I want to say this converges, this has to be what? Smaller than 1 over n squared. Well, that's where it gets hard sometimes, and it's hard to tell. I don't know if that's smaller than 1 over n squared. I don't know for sure. Okay, well, if you don't know for sure, you're going to use something called a limit comparison test. And you're going to set up a ratio between the given term generator and the one you're comparing it to. And we're going to do a limit as n goes to infinity, and you're going to find out some more information. So let's write down the limit comparison test, and then we'll complete this problem. Okay?
You can't just tell from the highest exponent.
You know what? What if I do this? What if I make it plus? Then you're a little less sure, right? Little less sure? Okay, well, we'll make it plus then, so I can make you as uncomfortable as possible.
If you make it plus, that means it's always going to be getting bigger in the denominator, which means it's also going to converge. Or am I just...
You're just. Like just for this one.
Suppose a sub n is greater than 0 and b sub n is greater than 0.
Wait, is this the one?
Yeah, I'm sorry, this is limit comparison test. limit comparison test. So suppose a sub n is greater than 0 and b sub n is greater than 0, and the limit as n approaches infinity of a sub n over b sub n equals L, where L is both finite and positive. So in other words, I have set up a ratio, right? I've got the term generator I was given divided by the term generator I'm comparing it to. If this is true, then the two series one to infinity of a sub n and 1 to infinity of b sub n either both converge or both diverge. A sub n is the term generator, and b sub n is what we choose for comparison. So we're going to take the term generator, we're going to divide it by the function we want to compare it to, and we're going to do a limit as n goes to infinity. If we get a finite positive number and what we chose to compare it to converged, then what do I get to say about the original? It also converges. If what I chose to compare it to diverged, it will also diverge. Okay? And again, it's because you're comparing growth rates. So let's go back to that example. We can make a plus. Okay, so you told me you wanted to compare it to 1 over n squared. Okay, and some of you are convinced that it's smaller and that it will converge, and that's fine. But if you're not, okay, then you want to do a limit comparison test to prove it to yourself. So I'm going to make myself a note here as I'm going through the problem because it's important that you remember if what you're comparing it to converges or diverges. Okay? So I'm going to compare to 1 over n squared, which is convergent p-series. Again, I'm just making myself some notes. Like I'm writing down the thought process I would be going through if I were doing this problem. So I'm going to set up a limit as n goes to infinity. And I'm going to write down the term generator. And I'm going to divide it by what I'm comparing it to. Dividing by a fraction is the same as multiplying by the reciprocal. So this turns into this. I'm now doing a limit as n goes to infinity. And what do I need to compare? Or what do I need to look at if I'm doing a limit as n goes to infinity? The highest degreed terms, right? The highest degreed terms. So this is 1/3. So since the limit produced a finite positive value, and B sub n converged, the original series also converges.
Finite positive what
Value. So I'm going to write down the homework, and I'm going to show you one more example. You don't have time to write it down. If you want to take a picture of it, you can. We're going to do 3 through 27 odd, 29 through 36. And I'll hand you that worksheet.
Is that a new workspace?
Yeah, it's a new worksheet. And then I'm going to just put this next example up here. So, original problem, it was that n to the 4th minus 10 over 4 n to the 5th minus n cubed plus 7. I needed to choose something to compare it to. And I compared it to 1 over n, because over n to the 5th would simplify to 1 over n. I know that 1 over n, I know that 1 over n is a divergent.
I already have this one.
Here, did you get this one? Did I give you 9-4 the other day when you were absent?
3.
Okay. Here's 9-4. Sure, I can scrape up.
I mean, is anything I can just take pictures off of another packet?
Do you mind doing it for right now? If I happen to locate one before you walk out of the room, I will give it to you.
Yeah, no, that's fine. I was not ready to take a quiz.
I found one. It actually has this.
Thank you.
Does this make sense? I'm just going to finish up this example in case anybody wants to hear it. So I would need to compare this to 1 over n, since if I simplify this, it gives me 1 over n. So again, I'm going to do the limit as n goes to infinity of the term generator I was given, divided by what I'm choosing to compare it to. I'm comparing it to a divergent p-series. I end up multiplying by the reciprocal. This becomes n to the 5th in the numerator. It's a limit as n is going to infinity, so I can just look at highest degree terms, and it simplifies to give me 1/4. So since the limit as n went toward infinity gave me a finite positive number, the original series will do exactly as the same thing as the series I compared it to. So since 1 over n diverged, this series will diverge by the limit comparison test.